Graphing linear relations, there are a few ways we now have that we can do this. But the most reliable, and maybe not the most efficient, but something we can always do for any function, for whether it be linear functions or really complicated functions, is we can generate a table of values. So I'm going to generate a table of values to graph this linear relation. Okay, we can see though that this has slope of 3 over 2, has a y-intercept of plus 4. So I'm going to start with maybe -2. And with -2, we plug in -2, x times, or 3 over 2 times -2 is going to be -3, plus 4 is going to be +1. So -2, +1. Make sure we're graphing accurately. Okay, make sure you're not mixing up your x's and y's. A point that we always want to put on the graph when possible is our x equals 0. And this works out to be our y-intercept of 4. I'm going to put in x equals 2, and we end up with y equals 7. And having those 3 points, that's pretty good. We can see that there is a straight line relationship, and we can sketch in our straight line through here. Okay, so with the table of values for straight lines, we can probably get away with 3 coordinates, although it's not a bad idea to have one more coordinate. So I'm going to plug in one more coordinate, so x equals 3. So we end up with, looks like in this case, 3 times 3 divided by 2 is 4.5. 4.5 plus 4 is 8.5. So at x equals 3, y equals 8.5. Yeah, that's a point on the line. So we can do this. We can always graph, and not just, again, this is not just for linear equations, but for any equations. We can graph by plugging in x's, solving for y's, and coming up with ordered pairs to put on our graph. The other way we did this is we could use our y-intercept starting point. We can use our slope of 2, 3 up, 2 across, and we can plot points, and we can get our pattern based on the slope and a starting point. So this is a function. So what is the value of y when x is 6? Well, we can just plug in a value of 6. Okay. We put it into our function. Our input is 6. Our output is going to be 13. Okay. So we can use this as our input and output. Okay, there's our x and y. So these all are connected. These ideas all are connected. Input, output, table of values, coordinate pairs on the graph. And x equals 6. It's going to go way off my graph here. So 6 and 13 is going to be way up here somewhere. Okay, so there's going to be my 6 and 13 coordinate. This equation is given to us in general form. We can rearrange this into y equals. Okay, so I'm going to subtract 2x from both sides. So I end up with y equals -2x plus 3. So this slope-intercept form is very useful for us to be able to graph with slope and intercept. We can much easier calculate values here. So I'm going to maybe start with -2. -2 times -2 is positive, so we get +7. Plot that ordered pair, so 2, 4, 6, 7. Okay, we should always plot our 0. X is 0, y is 3. Okay, maybe I'll plot x is 1, y is 1. And maybe we'll do x is 2, and we get y is equal to -1. Okay, and again, there's our straight line pattern. That's what we're looking for, that straight line pattern. And we could have, again, used the slope, the y-intercept of +3, and we could have used our slope progression of -2 over 1, -2 over 1 to plot points. And that would generate points that we can work out our pattern from.